Alright guys, so welcome back. Today we're going to start talking about a critical number. So what is a critical number? That's where you let f be defined as c. If f prime of c is equal to 0 or is not differentiable at c, then c is a critical number of f. So write that down, we'll talk about it. So what that's saying is when you take the derivative of your function and you set it equal to 0, you either will get a point there, you'll get some kind of x value, x is this point, so at this point you're going to have a tangent line there, you're going to have that slope of 0, or there's going to be cases where it does not exist. So if we take a look at this first picture, it's just an example. Right there is a that's an example of a maximum going on, and at that maximum point, my slope is 0. So at that point, that is my f prime of c equaling 0, because there's a horizontal tangent there. However, there are also examples that look like this, where my function is not differentiable at that point, and that will not exist. So both of those two are examples of critical points because they tell me something about my graph. Again, just like I talked about in the first video or yesterday, whenever you watched it, this is going to be leading up to something bigger, so we need to take those baby steps to get us to that bigger idea. Why do we care? We can clearly see that. Well, we'll see it in a couple lessons. So critical numbers are basically take the derivative, set it equal to 0. It tells me something cool about my graph. So let's do my examples. If you notice, my second one is different. I did not like the original one. It made it difficult, and I was trying to make it easy and nice for our first couple examples. And none of your homework questions look like that, so I decided to change it. So make sure you change that second problem. Okay, first steps first is we need to take the derivative of this guy. Well, I could if I wanted to do product rule with the first one, but I feel like that's going to make my life harder. I would like to just multiply in that 2x squared and then do difference, the difference rule. So if I multiply that in, that'll give me 4x cubed minus 12x squared. So now from this step, I'm going to go ahead and take the derivative, and I'm going to change colors so you can see that we changed something different. So I take the derivative of that guy. The 3 comes out with the 4 and then multiply, so I get 12x squared minus 24x. So now, changing colors again, my idea here is to set this equal to 0 and figure out where that will have a slope of 0. So I have 12x squared minus 24x equals 0. So I want to solve this. Typically, I want to factor it because it's quadratic. However, it's not going to give me two groups of factors, so I'm just going to go ahead and factor out a 12x from both pieces. When I do that, I'm left with x minus 2. And that's still equal to 0. Oops. So that means that since both things are equal to 0, that 12x equals 0 or x minus 2 equals 0. So x is 0 and x equals 2. So in this case, we have two critical points. We have two critical points at this part that would make my function that would make the slope 0. So when I plug in 0 and when I plug in 2, that'll give me a slope of 0. Alright, let's go ahead and do this next one. So same idea, I'm not going to do product rule, it's going to make my life too difficult. So I get 4x to the 4th minus 32x squared. Now I'm going to go ahead and take the derivative of that guy, so that's going to give me 16x cubed minus 64x. Okay, we're going to set that guy equal to 0. So I have 16x cubed minus 64x is 0. Again, we're going to factor some stuff out here. I can take out a 16 and an x. When I do that, I'm left with x squared minus 4. I can factor that set of parentheses again because it's the difference of two squares. So I have 16x times x minus 2, x plus 2. Just like the last thing, I can pull each part and set equal to 0. So in this case, we have 3 critical points. We have 0, we have 2, and we have negative 2. This will lead us to our next idea of finding the extrema on a closed interval. Okay, so extrema, again, are those critical points. They're finding the max and the minimum. First steps first is you're going to find the critical number of f in your interval. So basically what we just did. Then you're going to evaluate f at each critical point. Evaluate means to just plug it in. Then you're going to evaluate at each endpoint. So you're going to plug in each endpoint. And then you're going to get some values. So the smallest value will be your minimum. The largest value will be your maximum. Okay, so let's take a look at this example. We're going to look at this on the interval of, I meant to put that in there. So that's going to be on the interval of -1, 2. So we're going to be on that closed interval. These are the points we're going through. First steps first, it tells me to find the critical points. So I start by taking the derivative. So the derivative of the thing above, I don't have to multiply anything through. It makes it nice for me. It's 12x cubed minus 12x squared. Set that equal to 0. So 12x cubed minus 12x squared equals 0. Divide out my 12x squared. Left with x minus 1. So x is 0 and x is 1. So those are my critical points. Step number 2 tells me to evaluate each critical point of f. I'm going to do that next to it. So I'm going to have f of 0, which is 3 times 0 to the 4th minus 4 times 0 cubed, which gives me 0. Oops, no. What? Yes, I know math. And then I take f of my other one, which is 1. So it's 3 times 1 to the 4th minus 4 times 1 to the 3rd, which will give me -1. Step number 3 says I take my endpoints and I plug it in. So my endpoints are -1 and 2. So I'm going to have f of -1, which will be 3 times -1 to the 4th minus 4 times -1 to the 3rd, which gives me 7. And then I take f of the other endpoint, so in this case 2. I have 3 times 2 to the 4th minus 4 times 2 to the 3rd. And that gives me 16. And then what I'm going to do with all that information is I'm going to put it in a nice little table so I can see what my final answer is. So I have a left endpoint. I have a critical number because that's someplace on there. I have another critical number because we had 2 in this case. And I have a right endpoint. Okay, so my left endpoint was my smallest value of my my left endpoint of -1. When I plugged in that -1, my answer was 7. So I have a point of -1, 7. Let's take a look at my 2 critical points. I like to go in numerical order. So if I look at my 2 x values, I have 0 and 1. So when I plugged in 0, I got 0. So my first critical point will be 0, 0. Likewise, the next one would be 1, -1. And my right endpoint is when I plugged in that 2. So I get 2, 16. Because when I plug in 2, 16 is my output. So when that happens, on number 4, if I go back a second, it tells me I can find my minimum and my maximum. Now these values, my minimum and my maximum, are the absolute minimum and the absolute maximum of the function. So which y value is the smallest? Correct, the critical point. So this critical point is the absolute, or ABS, minimum. It means absolute minimum. It's the smallest point possible in this interval. Next, I want to look for my maximum. Oh, which one has the highest y value? My right endpoint. So this one is my absolute maximum. That's all I got for you.